This is question 4 from chapter 12G of the MathsQuest textbook. The question gives us that the force is equal to 1 plus sine 2t, and we're asked to find the speed at a particular point in time. So first of all, we're going to use Newton's laws and say that the force is equal to mass times acceleration. We now need to find the acceleration, so I'm going to divide both expressions by m in order to find the acceleration. So the acceleration is going to be equal to 1 over m plus 1 over m sine 2t. To find the velocity, we need to integrate the acceleration with respect to time. So that's going to give us 1 over m plus 1 over m sine 2t, and we're integrating that with respect to time, so the dt. Doing the integration, we're going to get t over m plus t over, sine will integrate to the cos 2t. Now we need to change the sign from a positive to a negative because cos differentiates to sine, and we need to divide by the 2 at the front. So, and then add on our constant. The next step we need to do is work out what is the value of this constant, and we're told that the object was starting from rest. So we can say that at time 0, the velocity is equal to 0. So we've got 0 is equal to, if we plug in 0 for the t, we get 0 minus 1 over 2m cos 0 plus c. Now, cos 0 is equal to 1, so that gives us that c is equal to 1 over 2m. We can now put this in and give our velocity equation as being t over m minus 1 on 2m cos 2t plus 1 over 2m. The question asks us to find the speed when the time is equal to pi on 2. So we're going to substitute that in. So v is going to be equal to pi on 2. We know that the mass was equal to 6 kilograms. Minus 1 over 2 times 6 cos 2 times pi on 2 plus 1 over 2 times 6. Simplifying that now, that gives us, we've got pi on 12 here. This is going to give us 1/12 because cos of pi will give us negative 1, and then we've got our 1 over 12 here. Simplifying that, we get that the speed is pi plus 2 over 12, and that will be in units of metres per second. For question B, we need to work out the distance travelled at that point in time. So we need to integrate the velocity with respect to time. So putting in our velocity equation that is up above, and we're integrating that with respect to time. So doing the integration, this t term will become t squared, and we need to divide by the 2. Our cos will change to sine. The negative will still stay because sine differentiates to a positive sign, but we also need to divide by an extra 2. So instead of having 2 on the bottom, we'll now have 4m, and then we'll have plus t over 2m plus c. We need to work out what the constant is again. So we know that at t equals 0, the displacement was equal to 0. So we can say that 0 is equal to 0 because it's 0 squared. Then sine of 0 is equal to 0. Then the next term is also 0 plus c. So obviously c is going to be equal to 0. So we know that r is t squared on 2m minus 1 over 4m sine 2t plus t over 2m. And we don't need to put the c in now. We're asked to find when t is equal to pi on 2, what is the displacement? So putting that in, we've got r is going to be equal to pi on 2 squared over 2m minus 1 over 4m sine 2 pi on 2 plus pi on 2 times our 2m. Okay, so expanding that further now, we've got pi squared on 2 squared is 4, times by the other 2 makes 8, and we've got to multiply by the mass, which is 6. 1 on 4 times 6. The 2's here cancel, so sine of pi will give us 0. And then we've got pi on 4 times 6 because our mass is 6. So we've got pi squared over 48 plus pi over 24. If we put those onto a common denominator of 48, we've got pi squared plus 2 pi as our displacement, and the units for that will be in metres.